try to solve Leetcode problem 1135, connecting cities with minimum cost. So we're having n cities labeled from 1 to 3. You're also giving an integer n, so n is the number of nodes, and we are also having connections. So connections is the edges. So for example, 1 and 2 connected. So this is an undirected graph. So the weight of the graph is 5. Weight of the edge from 1 and 2 is 5. So this is just the meanings of the connections. We're going to return the minimum cost to connect all the n cities, such that there is at least one path between each pair of cities. If it is not possible, we're going to return a -1. But basically, we need to connect all the cities, but we need to return the minimum cost. So the cost is the sum of the connections cost used. Yeah, let's try to make a drawing. So for this example, so for 1, 2, and 3, so for example, we can find a path. So for example, from 1 and 2 to 3. Now, the graph is connected. I mean, city 1, 2, and 3 is connected, but there's a weight of 5 and 1. So the total sum is 6, and 6 is going to be the minimum. We're going to find such a path. So if we are given a random graph like that, and we're going to check the path like this, so it's going to be the minimum spanning tree problem. So I'm going to call it MST. So there are two methods to solve this problem: the Prime's algorithm and Kruscal's algorithm. So I prefer to use Kruscal's algorithm. Basically, Kruscal algorithm is like that. We're gonna sort all the edges first, and then we're gonna use unified to connect all the edges. So for example, this is the shortest edge. We're gonna put it here. Maybe there's another longer edge. We're gonna put it here. Yeah. So we're gonna connect those two nodes and connect those two nodes in the unified. And then maybe there is a even longer edge. It's like that. Yeah. Now, what are we gonna do? We're gonna use all other left edges. So what is left? Maybe there's an edge. Yeah, the drawing is not so good, but let me try to make the drawing better. So yeah, because the edge has already been sorted, so the next one definitely is gonna be a little bit longer. So what about the next one? Definitely gonna be a little bit longer. So the first one, second one, and third one. Then we're gonna use the unified to union. If there's other edge, we are not sure, but if there is, maybe so this is the fourth edge, it is here. So basically we're gonna connect it. And then maybe we have another edge, so this edge is bigger than this one, and then others, maybe we're gonna connect it like that. Now this is our result, and we just need to sum up all the edges, and this is gonna be the final result. So this is the idea of the Kruscal's algorithm. First of all, we're gonna sort all the edges according to the weight in increasing order. So after that, we're gonna use unified to connect them. If they are not connected, we're gonna connect them. Yeah. But for our problem, we need to check how many edges. If the edges we are connecting is just n-1, because we have n nodes. If there are n-1 edges we are connecting, it means we've already found, so we can return the result. Yeah. But if it is a connected graph, yeah, if the edges is n-1, so it means we've already found, so we can return the result. If the edges is not n-1, we're gonna return a -1 according to the description of the problem. Yeah. As you can see it from here, so the edges is 2, it is not 3, so we're gonna return a -1. Now let's go. Let's start coding. So for this problem, I'm gonna use a template from unified. I'm not going to explain what is a unified because basically, the unified has already been explained in the unified topic. But for this one, it is the minimum spanning tree. So I don't think it is necessary to talk about what is unified and what is this template and how to write it. And basically, if you are familiar with unified, definitely you can write the unified template like this. So I just need to explain what is the meaning. So I have a parent array, I have a find and union, and I also have a isConnected method just to check if two nodes are connected or not. Yeah. Now let me just start coding. So most of the time I prefer to use unified for the minimum spanning tree. I prefer to use Kruscal's algorithm because it is faster. I didn't mean the time complexity is faster. I mean the coding is much faster because there's not so much coding and it's easier to code. So yeah, let's just prepare a sort. So we're gonna sort the connections first according to the weight. So k should equal to the lambda, and we're gonna check the third index x2. So it's gonna be the weight. So we're gonna sort the array according to sort all the edges according to the weight in increasing order. After that, we're gonna initialize the unified, and it's gonna be UFN. And for the node inside the unified, I prefer to use 0 to n-1, not 1, 2, 3, but 0, 1, and 2 for all the nodes. So I'm going to prepare a result array, and I'm going to also result variable and add variable starting from 0 and 0. So the result is going to be my final result. This edges is just to check how many edges. If the edge is equal to n-1, it means I can return the result. So I just need to loop through the array. So for UV and cost inside the connections. So if UF not connected, if not UF dot is connected, so here I'm gonna use U-1 and V-1. I've already explained I'm gonna use 0 to n-1 for all the nodes. Yeah, so if they are not connected, I'm gonna connect the two nodes, U-1 and V-1, and the edges would plus equal to 1, and the result would plus the cost. Yeah. So finally, I'm gonna have a return. We need to understand this kind of unified. So for this kind of unified, if we're gonna connect all the edges, no matter how many edges are inside the graph, no matter how many, this one is 3, maybe more, maybe we have more nodes, maybe we have 4 nodes, a lot of edges, maybe it is 6 edges. But what are we going to do for the unified? The unified will always connect a graph like this. It's going to be the minimum spanning tree. So this is why I just needed to return the final result. So I'm going to return the final result, but we need to check if the edge is equal to n-1 or not. If the graph is connected, definitely we can find. But if the graph is not connected, it has 2 connected components. Yeah, if it has 2 connected components, definitely we're going to return a -1. So we're going to have a check if edges equal to n-1. So we're going to return the result. Otherwise, we're going to return a -1. So this is for the second example. As you can see, there's not so much coding. And we can also analyze the time complexity easily. So this is just a sorting. That takes most of the time. So the length of the connections array, so for example, this is n. So this is n log n. And for here, this is just a unified. So this is n, and here is O1, because we can use the path compression or the racking to make the unified really fast. Basically, it's nearly to O1. So here is On, and here is n log n. So the time complexity is n log n. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it's pretty fast and it passed all the testing cases. Thank you for watching. See you next time.